Hello children, let us solve previous year's JEE questions. First question, the sum of solutions of the equation mod root x minus 2 plus root x into root x minus 4 plus 2 is equal to 0, where x is greater than 0 is equal to. These are the options given. This question was asked in JEE Mains 2019. The given equation is mod root x minus 2 plus root x into root x minus 4 plus 2 is equal to 0. Put root x is equal to t so that the calculation is easier. So the equation will be mod t minus 2 plus t into t minus 4 plus 2 is equal to 0. Critical point is t is equal to 2. So we will consider two cases, when t is greater than 2 and when t is less than 2. Case 1, when t is greater than 2. When t is greater than 2, mod t minus 2 will be written as plus t minus 2. So the equation will be t minus 2 plus t into t minus 4 plus 2 is equal to 0, or t into t minus 3 is equal to 0. So t is equal to 0 or t is equal to 3. Since t is greater than 2, so t is equal to 0 is rejected. So the solution in this case will be t is equal to 3. T is equal to root x. So root x is equal to 3. Square both the sides. So x is equal to 9. This is the solution in this case. Case 2, when t is less than 2. When t is less than 2, mod t minus 2 will be written as minus t minus 2. So the equation will be minus t minus 2 plus t into t minus 4 plus 2 is equal to 0, or t minus 1 into t minus 4 is equal to 0. So t is equal to 1 or t is equal to 4. Since t is less than 2, so t is equal to 4 is rejected. So solution in this case is t is equal to 1. T is equal to root x. So root x is equal to 1. Square both the sides, so x is equal to 1. So we have got two solutions. X is equal to 9 and x is equal to 1. So sum of solutions will be 9 plus 1, and that is 10. So the option C is correct. Second question, let S be the set of all real roots of the equation 3 to power x into 3 to power x minus 1 plus 2 is equal to mod 3 to power x minus 1 plus mod 3 to power x minus 2. Then S is. These are the options given. This question was asked in JEE Mains 2020. The given equation is 3 to power x into 3 to power x minus 1 plus 2 is equal to mod 3 to power x minus 1 plus mod 3 to power x minus 2. Put 3 to power x is equal to t so that calculation is easier. So the equation will be t into t minus 1 plus 2 is equal to mod t minus 1 plus mod t minus 2. Critical points are t is equal to 1 and t is equal to 2. So we will consider three cases: when t is less than 1, when t lies between 1 and 2, and when t is greater than 2. Case 1, when t is less than 1. When t is less than 1, both mod t minus 1 and mod t minus 2 will be negative. So the equation will be t into t minus 1 plus 2 is equal to minus t minus 1 minus t minus 2. So t is equal to minus 1 plus root 5 by 2 and t is equal to minus 1 minus root 5 by 2. This will give positive value of t and this will give negative value of t. T is equal to 3 to power x, and 3 to power x will always be positive whether x is positive or negative. So its value cannot be negative. So this solution is rejected. We will get only one solution here. Case 2, when t lies between 1 and 2. When t lies between 1 and 2, mod t minus 1 will be positive and mod t minus 2 will be negative. So equation in this case will be t into t minus 1 plus 2 is equal to t minus 1 minus t minus 2, or t is equal to 1 plus minus root 3i by 2. Both the roots will be complex, so no real solution in this case. Case 3, when t is greater than 2. When t is greater than 2, both mod t minus 1 and mod t minus 2 will be positive. So the equation will be t into t minus 1 plus 2 is equal to t minus 1 plus t minus 2. So t is equal to 3 plus minus root 11i by 2. So again, both the roots will be complex. So no real solution in this case as well. So finally, we will get only one solution from here. So set S will have only one element. So it is a singleton set. So option D is correct. Third question, the number of real roots of the equation e to power 4x plus e to power 3x minus 4 into e to power 2x plus e to power x plus 1 is equal to 0 is. These are the options given. This question was asked in JEE Mains 2020. The given equation is e to power 4x plus e to power 3x minus 4 into e to power 2x plus e to power x plus 1 is equal to 0. This can be written as e to power x to power 4 plus e to power x to power 3 minus 4 into e to power x to power 2 plus e to power x plus 1 is equal to 0. Put e to power x is equal to t so that calculation will be easier. So this equation becomes t to power 4 plus t cube minus 4t square plus t plus 1 is equal to 0. Now put t is equal to 1 to check whether t is equal to 1 is one solution of this equation or not. We get LHS is equal to RHS. That means t is equal to 1 is one solution of this equation. Or we can say t minus 1 is one factor of this expression. We can get other factors by following two methods. Method 1. Divide this expression by t minus 1. So we get t cube plus 2t square minus 2t minus 1 as other factors. Method number 2. We can write this expression as t to power 4 minus t cube plus 2t cube minus 2t square minus 2t square plus 2t minus t plus 1. So that we can take t minus 1 common in consecutive pair of terms starting from left hand side. So in term 1 and 2, if we take t cube common, we get t minus 1 in bracket. In term 3 and 4, if we take 2t square common, we get t minus 1 in bracket. In term 5 and 6, if we take minus 2t common, we get t minus 1 in bracket. In term 7 and 8, if we take minus 1 common, then we get t minus 1 in bracket. Now in these four terms, we can take t minus 1 common. So we get t minus 1 into t cube plus 2t square minus 2t minus 1. So we have factorized this expression as this. Now this equation means either t minus 1 is 0 or t cube plus 2t square minus 2t minus 1 is 0. Now we can factorize this expression following the same method starting from here. So this will be factorized as t minus 1 into t square plus 3t plus 1. So this expression is factorized as t minus 1 into t minus 1 into t square plus 3t plus 1. Now we can easily get roots of this equation t square plus 3t plus 1 is equal to 0. So the roots will be t is equal to minus 3 plus root 5 by 2 and minus 3 minus root 5 by 2. Value of t will be negative here and value of t will be negative here as well. So both roots are negative. T is equal to e to power x and e to power x will always be positive whether x is positive or negative. So both the roots being negative will be rejected. So finally we have got only one root and that is t is equal to 1. T is equal to e to power x. So e to power x is equal to 1. 1 can be written as e to power 0. On both the sides base is same and that is e. So we can equate exponents. So x is equal to 0. So x is equal to 0 is the only real root of this equation. So our answer is D. Fourth question, the probability of selecting integers a that belong to interval minus 5 to 30 such that x square plus 2 into a plus 4 into x minus 5a plus 64 is greater than 0 for all x that is real is. These are the options given. This question was asked in JEE Mains 2021. Recall this graph. We know that if the sign of expression ax square plus bx plus c is positive for all x that is real, that means a is greater than 0 and d is less than 0. Here a is coefficient of x square and d is discriminant. Coefficient of x square is 1 and 1 is greater than 0. So a is greater than 0. Now we will form this inequality, d is less than 0. Compare the given expression with ax square plus bx plus c. So we get a is equal to 1, b is equal to 2 into a plus 4 and c is equal to minus 5a plus 64. So discriminant d is equal to b square minus 4ac. So d is simplified as 4 into a plus 16 into a minus 3. D is less than 0. So the inequality is 4 into a plus 16 into a minus 3 is less than 0. Critical points are minus 16 and plus 3. To solve this inequality, draw a number line and mark the points 3 and minus 16. Draw a wavy curve starting from top right and passing through 3 and minus 16. Inequality is less than 0. So we need to consider the zone below the number line. So A lies between minus 16 to plus 3. So all the possible values of A can be minus 15, minus 14, minus 13 and so on up to plus 2. Suppose this is point number 1. It is given that A belongs to the interval minus 5 to plus 30. So as per this interval, possible values of A can be minus 5, minus 4, minus 3 and so on up to plus 30. Suppose this is point number 2. Now we will take common from point number 1 and point number 2 to say that all the possible values of A will be minus 5, minus 4, minus 3 and so on up to plus 2. They are 8 in number. Total possible values of A in this interval will be 36. Count minus 5, minus 4, minus 3 and so on up to plus 30. So they will be 36 in number. So the probability will be number of possible outcomes of A upon total number of outcomes of A, and that is 8 upon 36. So it will be 2 upon 9. So our option will be option B is correct. Fifth question, the number of all possible positive integral values of alpha for which the roots of the quadratic equation 6x square minus 11x plus alpha is equal to 0 are rational numbers is. These are the options given. This question was asked in JEE Mains 2019. The given quadratic equation is 6x square minus 11x plus alpha is equal to 0. So we can find its roots by the formula x is equal to minus b plus minus under root b square minus 4ac upon 2a. So the roots are 11 plus minus under root 121 minus 24 alpha upon 12. It is given that roots are rational numbers. That means this under root sign should not be there. Or in other words, 121 minus 24 alpha should be perfect square. It is also given that alpha can take positive integral values. So we will put values of alpha as 1, 2, 3 and so on to see for which values of alpha 121 minus 24 alpha is perfect square. So let us start putting the values of alpha as 1, 2, 3 and so on. When alpha is equal to 1, value of 121 minus 24 alpha is 97 and 97 is not a perfect square. When alpha is equal to 2, value of 121 minus 24 alpha is 73, which is not a perfect square. When alpha is 3, value of 121 minus 24 alpha is 49, which is perfect square of 7. When alpha is 4, value of 121 minus 24 alpha is 25, which is perfect square of 5. When alpha is equal to 5, value of 121 minus 24 alpha is 1, which is perfect square of 1. We have to stop here because when we put alpha is equal to 6, value of 121 minus 24 alpha will be negative. So the roots will be complex conjugate, but it is given that roots are rational numbers. So we have found the values of alpha as 3, 4 and 5 for which 121 minus 24 alpha will be perfect square. So number of values of alpha will be 1, 2 and 3. So the number of all possible positive integral values of alpha will be 3. So option C is correct. Sixth question, let alpha is equal to maximum of 8 to power 2 sine 3x into 4 to power 4 cos 3x where x is real. And beta is equal to minimum of 8 to power 2 sine 3x into 4 to power 4 cos 3x where x is real. If 8x square plus bx plus c is equal to 0 is a quadratic equation whose roots are alpha to power 1 by 5 and beta to power 1 by 5, then the value of c minus b is equal to. These are the options given. This question was asked in JEE Mains 2021. It is given that alpha is equal to maximum of this. First, we will simplify this part. 8 can be written as 2 to power 3 and 4 can be written as 2 to power 2. Now powers will be multiplied. So this part will be 2 to power 6 sine 3x and this part will be 2 to power 8 cos 3x. Now bases are same, so powers will be added up. So this can be written as 2 to power 6 sine 3x plus 8 cos 3x. Now this will be maximum when power is maximum and this will be minimum when power is minimum. So suppose power is equal to a. So at maxima or minima, dA upon dx is equal to 0. So this gives tan 3x is equal to 3 by 4. Make a right angle triangle to figure out sin 3x and cos 3x. So sin 3x is equal to 3 by 5 and cos 3x is equal to 4 by 5. Tan theta is positive in first and third quadrants. So A will be maximum in first quadrant where sin theta and cos theta both will be positive. And A will be minimum in third quadrant where sin theta and cos theta both will be negative. So let us find out maximum and minimum values of A. So A maximum will be equal to 6 into sin 3x, that is plus 3 by 5, plus 8 into cos 3x, and that is plus 4 by 5. So A maximum will be equal to 10. So alpha is equal to 2 to power 10. Similarly, we will calculate A minimum when sin theta and cos theta both will be negative. So A minimum is equal to 6 into minus 3 by 5 plus 8 into minus 4 by 5. So A minimum is equal to minus 10. So beta is equal to 2 to power minus 10. We have got the values of alpha and beta. So alpha to power 1 by 5 is equal to 4 and beta to power 1 by 5 is equal to 1 by 4. We have got alpha to power 1 by 5 equal to 4 and beta to power 1 by 5 equal to 1 by 4. These are the roots of the given quadratic equation 8x square plus bx plus c is equal to 0. So sum of the roots is equal to minus b by 8 and product of the roots is equal to c by 8. So from these we get value of b is equal to minus 34 and value of c is equal to 8. So value of c minus b is equal to 42. So the option A is correct. Seventh question, let lambda is not equal to 0 be in R, that is real number set. If alpha and beta are the roots of the equation x square minus x plus 2 lambda is equal to 0 and alpha and gamma are the roots of the equation 3x square minus 10x plus 27 lambda is equal to 0, then beta gamma upon lambda is equal to. These are the options given. This question was asked in JEE Mains 2020. It is given that alpha and beta are roots of the equation x square minus x plus 2 lambda is equal to 0. So we can write alpha plus beta is equal to 1 and alpha beta is equal to 2 lambda. Also, it is given that alpha and gamma are roots of the equation 3x square minus 10x plus 27 lambda is equal to 0. So alpha plus gamma is equal to 10 by 3 and alpha gamma is equal to 9 lambda. It is given that alpha is one root of the equation x square minus x plus 2 lambda is equal to 0. So x is equal to alpha should satisfy this equation. That means alpha square minus alpha plus 2 lambda is equal to 0. Also, it is given that alpha is one root of this equation as well. So x is equal to alpha should satisfy this equation as well. So 3 alpha square minus 10 alpha plus 27 lambda is equal to 0. We can solve equation number 5 and 6 to get alpha is equal to 3 lambda. Put the value of alpha in equation number 1 to get the value of beta is equal to 1 minus 3 lambda. Put the values of alpha and beta in equation number 2 to get the value of lambda is equal to 1 by 9. Now put the value of lambda in equation number 8 and 9 to get the values of alpha and beta. So alpha is equal to 1 by 3 and beta is equal to 2 by 3. Now from equation number 4, put the value of alpha and lambda to get the value of gamma. So gamma is equal to 3. Now we have got the values of beta, gamma and lambda. So beta gamma upon lambda is equal to 18. So option D is correct. 8th question, if alpha and beta are distinct roots of the equation x square plus 3 to power 1 by 4x plus 3 to power 1 by 2 is equal to 0, then the value of alpha to power 96 into alpha to power 12 minus 1 plus beta to power 96 into beta to power 12 minus 1 is equal to. These are the options given. This question was asked in JEE Mains 2021. The given equation is x square plus 3 to power 1 by 4x plus 3 to power 1 by 2 is equal to 0. Put 3 to power 1 by 4 is equal to t, so that calculation will be easier. So the given equation will be x square plus tx plus t square is equal to 0. Its roots alpha and beta can be calculated by the formula minus b plus minus under root b square minus 4ac upon 2a. So the roots will be minus t plus minus under root 3ti by 2. Suppose alpha is equal to minus t plus root 3ti by 2. So beta will be equal to minus t minus root 3ti by 2. Alpha can be written as, take t common here, so in bracket it will be minus 1 by 2 plus root 3 by 2i. Minus 1 by 2 can be written as cos 2 pi by 3 and root 3 by 2 can be written as sin 2 pi by 3. So alpha is equal to t into cos 2 pi by 3 plus I sin 2 pi by 3. Similarly, beta can be written as, take minus t common here. So it will be minus t into in bracket 1 by 2 plus root 3 by 2i. 1 by 2 can be written as cos pi by 3 and root 3 by 2 can be written as sin pi by 3. So beta is equal to minus t into cos pi by 3 plus I sin pi by 3. Now we are ready to calculate alpha to power 12, alpha to power 96, beta to power 12 and beta to power 96. Alpha to power 12 is equal to t to power 12 into cos 2 pi by 3 plus I sin 2 pi by 3 to power 12. We can apply the Navier theorem in this part. So power will be multiplied with the angles. So this part will be cos 8 pi plus I sin 8 pi. This is in the form cos 2n pi whose value is 1. This is in the form sin 2n pi whose value is 0. So alpha to power 12 is equal to t to power 12 into 1 plus 0 and that is equal to t to power 12 and t is equal to 3 to power 1 by 4. So alpha to power 12 is equal to 27. Similarly, we can calculate alpha to power 96, beta to power 12 and beta to power 96. So the value of alpha to power 96 into alpha to power 12 minus 1 plus beta to power 96 into beta to power 12 minus 1 is equal to 52 into 3 to power 24. So the correct option is option C. 9th question, if alpha and beta are the roots of the quadratic equation x square plus x sin theta minus 2 sin theta is equal to 0, where theta lies between 0 to pi by 2, then alpha to power 12 plus beta to power 12 upon alpha to power minus 12 plus beta to power minus 12 into alpha minus beta to power 24 is equal to. These are the options given. This question was asked in JEE Mains 2019. It is given that alpha and beta are roots of the quadratic equation x square plus x sin theta minus 2 sin theta is equal to 0. So we can write alpha plus beta is equal to minus sine theta and alpha beta is equal to minus 2 sine theta. The given expression is alpha to power 12 plus beta to power 12 upon alpha to power minus 12 plus beta to power minus 12 into alpha minus beta to power 24. We will simplify this expression first. Alpha to power minus 12 can be written as 1 by alpha to power 12. Similarly, beta to power minus 12 can be written as 1 by beta to power 12. We will take LCM of this part, and the LCM will be alpha to power 12 into beta to power 12. In numerator, it will be beta to power 12 plus alpha to power 12. Now, alpha to power 12 into beta to power 12 will go into numerator, and this part will get cancelled. So, expression is simplified as alpha to power 12 into beta to power 12 upon alpha minus beta to power 24. Alpha to power 12 into beta to power 12 can be written as alpha beta whole to power 12. And alpha minus beta to power 24 can be written as alpha minus beta whole square whole to power 12. Now we will use this identity. Alpha minus beta whole square is equal to alpha plus beta whole square minus 4 alpha beta. Value of alpha plus beta and alpha beta we will put from equation number 1 and 2. So alpha minus beta whole square is equal to sine square theta plus 8 sine theta. Now we will put the values of alpha beta and alpha minus beta whole square from equation number 2 and 3. So the expression is simplified further as 2 to power 12 upon sine theta plus 8 to power 12. So option D is correct. 10th question. Let alpha and beta be two real numbers such that alpha plus beta is equal to 1 and alpha beta is equal to minus 1. Let Pn is equal to alpha to power n plus beta to power n. Pn minus 1 is equal to 11 and Pn plus 1 is equal to 29. For some integer n is greater than or equal to 1. Then the value of Pn square is. This question was asked in JEE Mains 2021. It is given that sum of the roots is equal to 1 and product of the roots is equal to minus 1. So the quadratic equation will be x square minus sum of the roots into x plus product of the roots is equal to 0. So quadratic equation will be x square minus x minus 1 is equal to 0. Alpha is one root of this equation. So x is equal to alpha will satisfy this equation. So we can say that alpha square minus alpha minus 1 is equal to 0, or alpha square is equal to alpha plus 1. 1 can be written as alpha to power 0. So in terms of power, it can be read as alpha to power 2 is equal to alpha to power 1 plus alpha to power 0. Now replace 2 by n plus 1. So alpha to power n plus 1 is equal to alpha to power n plus alpha to power n minus 1. When n is equal to 1, this will be true. Now beta is another root of the same equation. So in the same way, we can say that beta to power n plus 1 is equal to beta to power n plus beta to power n minus 1. It is given that Pn is equal to alpha to power n plus beta to power n. So Pn plus 1 is equal to alpha to power n plus 1 plus beta to power n plus 1. And Pn minus 1 is equal to alpha to power n minus 1 plus beta to power n minus 1. Now we can add equation number 3 and 8. So on the left hand side, it will be alpha to power n plus 1 plus beta to power n plus 1. And on the right hand side, it will be alpha to power n plus alpha to power n minus 1 plus beta to power n plus beta to power n minus 1. Now alpha to power n plus beta to power n is equal to Pn. Alpha to power n minus 1 plus beta to power n minus 1 is equal to Pn minus 1. And alpha to power n plus 1 plus beta to power n plus 1 is equal to Pn plus 1. So Pn plus 1 is equal to Pn plus Pn minus 1. It is given that Pn plus 1 is equal to 29 and Pn minus 1 is equal to 11. So Pn is equal to 18, or Pn square is equal to 18 square, and that is 324. So we will fill 324 here. 11th question. Suppose a and b denote the distinct real roots of the quadratic polynomial x square plus 20x minus 2020, and suppose c and d denote the distinct complex roots of the quadratic polynomial x square minus 20x plus 2020. Then the value of AC into A minus C plus AD into A minus D plus BC into B minus C plus BD into B minus D is. These are the options given. This question was asked in JEE Advanced 2020. It is given that A and B are roots of the quadratic equation x square plus 20x minus 2020 is equal to 0. So we can write A plus B is equal to minus 20 and AB is equal to minus 2020. It is also given that C and D are roots of the quadratic equation x square minus 20x plus 2020 is equal to 0. So we can write C plus D is equal to 20 and CD is equal to 2020. The given expression is AC into A minus C plus AD into A minus D plus BC into B minus C plus BD into B minus D. First, we will open the brackets, then regroup the terms so that we can utilize these values. So when we open the bracket, this expression will be a square c minus ac square plus a square d minus ad square plus b square c minus bc square plus b square d minus bd square. If we pair up the terms a square c and a square d, we can take a square common so that in bracket it will be c plus d. We can put this value of c plus d is equal to 20. The same idea is extended for other terms as well. We will pair up the terms like this: a square c plus a square d minus ac square plus bc square minus ad square plus bd square plus b square c plus b square d. Now we will take common. So in term 1 and 2, a square is taken common, so it is c plus d minus c square into a plus b minus d square into a plus b plus b square into c plus d. Now we will put the values of a plus b and c plus d from equation number 1 and 3. So the expression will be simplified as 20 into a square plus c square plus d square plus b square. Now we will pair up these terms, a square and b square and c square and d square. So the expression is written as 20 into a square plus b square paired up plus c square plus d square paired up. Now to get the values of these, we will use the identity a square plus b square is equal to a plus b whole square minus 2ab. Value of a plus b and ab we will put from equation number 1 and 2. So a square plus b square is equal to 400 plus 40. Similarly, c square plus d square is equal to c plus d whole square minus 2cd. Value of c plus d and cd we will put from equation number 3 and 4. So c square plus d square is equal to 400 minus 40. So the value of expression will be 20 into a square plus b square is 400 plus 40 plus c square plus d square will be 400 minus 40. So finally, value of the expression comes out to be equal to 16,000. So option D is correct. Last question. Let alpha and beta be the roots of x square minus x minus 1 is equal to 0 with alpha greater than beta. For all positive integers n, define an is equal to alpha to power n minus beta to power n upon alpha minus beta, where n is greater than or equal to 1. b1 is equal to 1 and bn is equal to an minus 1 plus an plus 1, where n is greater than or equal to 2. Then which of the following options are correct? These are the 4 statements. We have to verify which statement is correct and which is not. There may be more than one correct statement. This question was asked in JEE Advanced 2019. It is given that alpha and beta are roots of the quadratic equation x square minus x minus 1 is equal to 0. So we can write alpha plus beta is equal to 1 and alpha beta is equal to minus 1. Statement A. a1 plus a2 plus a3 plus and so on up to an is equal to an plus 2 minus 1 for all n is greater than or equal to 1. It is given that an is equal to alpha to power n minus beta to power n upon alpha minus beta. So put n is equal to 1. So a1 will be equal to alpha minus beta upon alpha minus beta. a2 will be equal to alpha square minus beta square upon alpha minus beta. a3 will be equal to alpha cube minus beta cube upon alpha minus beta, and so on. So a1 plus a2 plus a3 plus and so on up to an is equal to alpha minus beta plus alpha square minus beta square plus alpha cube minus beta cube plus and so on up to alpha to power n minus beta to power n upon alpha minus beta. Now numerator can be written as alpha plus alpha square plus alpha cube plus and so on up to alpha to power n minus beta plus beta square plus beta cube plus and so on up to beta to power n. Now these are two GPs with n terms. So sum of n terms of a GP series is given by the formula a into 1 minus r to power n upon 1 minus r, where a is first term, r is the common ratio, and n is the number of terms. So sum of this GP series will be equal to alpha into 1 minus alpha to power n upon 1 minus alpha. And sum of this GP series will be equal to beta into 1 minus beta to power n upon 1 minus beta. Value of 1 minus alpha is equal to beta, and value of 1 minus beta is equal to alpha from equation number 1. Now we will take LCM of denominator. So it will be alpha beta. So numerator in bracket will be alpha square into 1 minus alpha to power n minus beta square into 1 minus beta to power n. So it can be simplified as alpha square minus beta square minus alpha to power n plus 2 plus beta to power n plus 2. Alpha square minus beta square can be written as alpha plus beta into alpha minus beta. And value of alpha beta is equal to minus 1 from equation number 2. So this can be simplified further as alpha to power n plus 2 minus beta to power n plus 2 minus alpha plus beta into alpha minus beta upon alpha minus beta. Now we can separate this into two terms. So first term will be alpha to power n plus 2 minus beta to power n plus 2 upon alpha minus beta, minus second term will be minus alpha plus beta. Value of alpha plus beta is equal to 1, and this is equal to a n plus 2 from here. A n is equal to alpha to power n minus beta to power n upon alpha minus beta. So a n plus 2 is equal to alpha to power n plus 2 minus beta to power n plus 2 upon alpha minus beta, which is the same. So this can be simplified as a n plus 2 minus 1, which is right hand side. So statement A is correct. Statement B. Summation of a n upon 10 to power n from n is equal to 1 to infinity is equal to 10 by 89. Left hand side is summation of a n upon 10 to power n from n is equal to 1 to infinity. Given that a n is equal to alpha to power n minus beta to power n upon alpha minus beta. So this is equal to summation of alpha to power n minus beta to power n upon alpha minus beta into 10 to power n from n is equal to 1 to infinity. Now this can be split into two terms. Take 1 upon alpha minus beta outside. So inside the bracket it is summation of alpha to power n upon 10 to power n from n is equal to 1 to infinity minus summation of beta to power n upon 10 to power n from n is equal to 1 to infinity. This can be expanded as alpha by 10 plus alpha square by 10 square plus alpha cube by 10 cube plus and so on up to infinity. Put the values of n as 1, 2, 3 and so on up to infinity. Similarly, this can be expanded as beta by 10 plus beta square by 10 square plus beta cube by 10 cube plus and so on up to infinity. This is infinite GP series and this is also infinite GP series. Sum of an infinite GP series is given by the formula a upon 1 minus r, where a is first term and r is the common ratio. So sum of this infinite series will be equal to alpha by 10 upon 1 minus alpha by 10. And sum of this infinite series will be given by beta by 10 upon 1 minus beta by 10. This is simplified as alpha upon 10 minus alpha, and this is simplified as beta upon 10 minus beta. Now we can simplify further. up to this point 10 upon 100 minus 10 into alpha plus beta plus alpha beta. Values of alpha plus beta and alpha beta we will put from equation number 1 and 2. So finally the value comes out to be equal to 10 by 89, which is right hand side. So statement B is also correct. Statement C, summation of Bn upon 10 to power n from n is equal to 1 to infinity is equal to 8 by 89. Left hand side is summation of Bn upon 10 to power n from n is equal to 1 to infinity. Given Bn is equal to an minus 1 plus an plus 1. So this is equal to summation of an minus 1 plus an plus 1 upon 10 to power n from n is equal to 1 to infinity. An minus 1 is equal to alpha to power n minus 1 minus beta to power n minus 1 upon alpha minus beta. And an plus 1 is equal to alpha to power n plus 1 minus beta to power n plus 1 upon alpha minus beta. So this can be simplified as alpha to power n minus 1 plus alpha to power n plus 1 minus beta to power n minus 1 minus beta to power n plus 1 upon alpha minus beta into 10 to power n from n is equal to 1 to infinity. Now this can be split into 4 terms. Take 1 upon alpha minus beta outside. So inside the bracket it is summation of alpha to power n minus 1 upon 10 to power n from n is equal to 1 to infinity plus summation of alpha to power n plus 1 upon 10 to power n from n is equal to 1 to infinity minus summation of beta to power n minus 1 upon 10 to power n from n is equal to 1 to infinity minus summation of beta to power n plus 1 upon 10 to power n from n is equal to 1 to infinity. This can be expanded as alpha to power 0 upon 10 plus alpha upon 10 square plus alpha square upon 10 cube plus and so on up to infinity. Put the values of n equal to 1, 2, 3 and so on up to infinity. Similarly, these all can be expanded like these. These 4 are infinite GP series whose sum is given by the formula a upon 1 minus r, where a is first term and r is the common ratio. So here first term is 1 by 10 and common ratio is alpha by 10. So this is 1 upon 10 upon 1 minus alpha by 10. Similarly, we can find the sum of other infinite GP series. So this can be simplified as 12 by 89. But right hand side here is 8 by 89. So this statement is wrong. Statement D. Bn is equal to alpha to power n plus beta to power n for all n greater than or equal to 1. Left hand side is Bn and given Bn is equal to an minus 1 plus an plus 1. An minus 1 is equal to alpha to power n minus 1 minus beta to power n minus 1 upon alpha minus beta. And an plus 1 is equal to alpha to power n plus 1 minus beta to power n plus 1 upon alpha minus beta. Take 1 upon alpha minus beta common. So inside the bracket it is alpha to power n minus 1 plus alpha to power n plus 1 minus beta to power n minus 1 minus beta to power n plus 1. If we can replace this by alpha minus beta into alpha to power n plus beta to power n, then alpha minus beta will get cancelled and right hand side will be equal to alpha to power n plus beta to power n. So statement D will be correct. So let us multiply and verify. Left hand side is alpha minus beta into alpha to power n plus beta to power n. So after multiplication it will be alpha to power n plus 1 plus alpha beta to power n minus alpha to power n beta minus beta to power n plus 1. Take alpha beta common in term 2 and 3. So inside the bracket it is beta to power n minus 1 minus alpha to power n minus 1. Put the value of alpha beta is equal to minus 1 from equation number 2. So it is simplified as alpha to power n minus 1 plus alpha to power n plus 1 minus beta to power n minus 1 minus beta to power n plus 1, which is right hand side. So we can replace this by alpha minus beta into alpha to power n plus beta to power n. So alpha minus beta will get cancelled and right hand side is equal to alpha to power n plus beta to power n. So here the right hand side is same. So statement D is also correct. So finally, correct statements are A, B and D. In next video, we will start chapter number 5, and that is permutations and combinations. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.